Hello guys, today we are going to solve absolute value inequalities. So that is our goal for today, and let's get started. So absolute value inequalities for all real numbers A and B being greater than 0, the following statements are true. First of all, if the absolute value of A is less than B, then we are going to use the little trick to remember this. By instead of saying less than, we're going to say less than, and I'm underlining the A and D because whenever you have a less than symbol on the right side of your absolute value, then we are going to make this an and compound inequality. So I have A is less than B and A is also greater than negative B. So what would this look like? Remember that this sort of compound inequality is the type where we have two solutions that overlap. Those are the and inequalities. We're looking for the overlap, the intersection of the two of them. Okay, so then that is for less than. Now let's look at number 2, and we have the absolute value of A is greater than B. So we are going to use TOR. So whenever you see the greater than inequality symbol, this is going to turn into an or inequality. So in this case, A is greater than B, or A is less than negative B. So remember that or inequalities look like the type where the solution is two separate parts, but we include both parts in the solution, so we would join these two sets together with the union. So let's do an example. The absolute value of Q is greater than or equal to 2. So first thing we notice is that the absolute value is by itself, so we can start setting this up into our two separate inequalities. So we have a greater than symbol, so we are going to use greater to set up two or inequality equations. So we have Q is greater than 2, or Q is less than negative 2. Notice that in the second equation, we've flipped the inequality sign as well as the sign of the solution. So we have negative 2, which is the opposite of positive 2. Okay, so what does this look like on a number line? Well, graphing 2 on either side, positive 2 and negative 2. Q is greater than 2, so we're going to go to the right, while Q is less than negative 2, that heads to the left. Our solution is the union of these two sets, so that means that our solution is including both of these sets. So how would we write this in interval notation? Well, we're coming from negative infinity and stopping at negative 2, including negative 2 since it's greater than or equal to, then joining with the right half of the number line starting at 2 and going toward infinity. Now let's do another example. We have the absolute value of x is less than 4. Remember, less than is when we're going to use the A and D and make this a compound inequality using the word and. So we start with our original, x is less than 4, insert the word and our second inequality again takes the opposite inequality sign and opposite number. So it went from positive 4 to negative 4. So let's graph this on a number line and see what this looks like. So we are going to put 2 points at positive 4 and at negative 4. We have x is less than positive 4, so that heads to the left. We have x is greater than negative 4, so that heads to the right. And our solution, since this is an and inequality, is where these two solutions overlap. So our final solution set is in between negative 4 and positive 4. Let's try this last example. We have the absolute value of negative 5j minus 4 is greater than or equal to 12. First of all, the absolute value is isolated. It's by itself. It does not have any coefficient in front that we need to get rid of or subtract away. So let's start solving. Notice that it's a greater than symbol, so we are going to use greater, Greator. This will be an or inequality, So we start with our original. Negative 5j minus 4 is greater than 12. Insert the word or, and negative 5j minus 4. Now we flip the inequality sign and take the opposite of the original. So is less than or equal to negative 12. And now we solve each inequality separately. So we'll start by adding 4 to both sides. Negative 5j is greater than 16. Divide by negative 5 on both sides. And j is now less than or equal to negative 3.2. So this inequality symbol changed from greater than to less than because we divided by a negative, so we needed to flip the sign. Okay, now let's solve the right-hand side. So we're going to, again, start by adding 4. So we are left with negative 5j is less than or equal to negative 8. Divide by negative 5. Again, being careful because since we are dividing by a negative, this inequality symbol flips. Now j is greater than or equal to 1.6. So we have our two solution sets. Let's graph these. So our first set is that j is less than or equal to negative 3.2. So I find negative 3.2 and I am showing that my graph goes to the left because our j values are less than negative 3.2. Or I can also include my j values to the right greater than 1.6. So my solution consists of both of these sets. So now when I write my interval notation, I need to join those two sets starting from left to right, negative infinity to negative 3.2, and close it off with a bracket because it's greater than or equal to. And then finally the union, joining with the right side, starting at 1.6 and going to positive infinity. So now if you flip to the back of the page, there are two problems for you to try on your own. You can see that the answers are in the bottom right-hand corner, so make sure that you try these problems on your own and write down any questions that you have so we can go over them in class tomorrow. And we'll spend lots of time practicing these absolute value inequalities. Thanks for tuning in.